Good morning, my dear friends. Today I'll be talking about a small topic called lasers, and hopefully by the end of the topic you get a general idea of what lasers are and what their general purpose is and what they're used for and how they exactly work. So, what is a laser exactly? Now, a laser by itself is light amplification by stimulated emission of radiation. Now, we can also understand by the basic principles that some of the important topics within lasers also include absorption, spontaneous emission, stimulated emission, population inversion, and a small topic called optical pumping, which we won't be discussing about in this video. Now, objectives. Now, the characteristics properties of laser lights themselves include coherence, high intensity, high directionality, and high chromaticity. A laser light is a highly powerful and it is capable of propagating over long distances, and it is not easily absorbed by water. Now, when we're talking about lasers, we'll also have to be talking about many different topics within lasers itself. For example, absorption, emission, coherence, and etc. So, if we're talking about absorption as such, we'll be talking about how energy, once it's given in the form of a photon, say to an electron in a lower energy level, which is then pushed upward to a higher energy level, we can say that it's gained energy, in which case it moves from E1 to E2 as such. The exact same opposite is possible when energy, or in the form of a photon, is released when the electron jumps down from a high energy level to a lower energy level. In this case, energy is emission has taken place. As such, we can actually talk about more different topics about emission as itself, but it generally means that an electron moves from a higher energy level to a lower energy level. We're also going to be talking about what we call simulated emissions. It actually takes place when an electron, which is actually present at a higher energy level, drops down to a lower energy level under the influence of a photon, which is sent to the electron. So we can say that the photon, once it's sent to the electron, causes the electron to jump from a higher energy level to a lower energy level, as such releasing its own energy as well, along with the photon that we've released. We can also talk about population inversion. It is also the process of increasing the excited electrons in higher energy levels. Due to this process, the production of laser is possible. Mainly, population inversion is the core of the reason why lasers are possible today, these days. The energy level between the ground state of first energy level and the excited energy level, or the third level, is known as metastable state, E2, or the second level. Optical pumping can be generally ignored from this point. But we could actually be distributing about the Planck's radiation law or the Boltzmann distribution law, but the lack of time prevents me from jumping into these topics as well. But going into the type of lasers that we do know, we can say there's the solid laser or the ruby laser, liquid laser, or we can say the gas laser. We'll mainly be talking about the solid and the gas laser for today. Now, the ruby laser is generally made up of the ruby crystal, as such from the name. Ruby itself is an aluminum oxide crystal, Al2O3, in which some of the aluminum atoms have been replaced with chromium atoms, 0.05% of its weight. Ruby crystal is actually formed into a cylinder. The ruby laser is used as a pulse laser, producing a red light around 6,940 angstrom. We can also say that the ruby crystal itself is surrounded by a xenon tube. Ruby crystal is fully silvered at one side and partially silvered at the other, just to give a general description of how the structure is made. We can also say that ruby crystals themselves absorb most of the light from the green and the blue spectrum, thus giving us the bright red we know the ruby crystal to be colored for. We also know that the third level and fourth level energy states is also possible, especially during the energy distribution. In a sense, what I mean is that when we say that an electron can actually jump between one level, it's not only limited to one level, it actually can jump to multiple levels and also can be dropping down by multiple levels. And as such, the energy released from these levels is added or subtracted as such. We can say that an electron generally is in its metastable state and they remain there for a certain period of time. For example, in this case, it can be around electron in a higher energy state is usually metastable for around 10 raised to the power minus 6 seconds. Moving onwards, we can also say that when the intensity of light beam is increased, we can also say that the energy which is absorbed or radiated is also increased or decreased as such. Ruby lasers have a large amount of popular uses, but they have mainly been extensively used in tattoo and hair removal, and they've also been used in non-destructive testing labs for holograms of large objects, etc. We can also say some of the disadvantages include that the efficiency of a ruby laser is very low as compared to other forms of lasers. Generally touching upon the other type of lasers, which include the gaseous laser, the helium neon laser. It's an atomic laser which employs a 4-level pumping system. Not going into the details of that. They usually have neon centers. Their common wavelength is around 6,320 angstrom, and operating life at the order of around maybe 50,000 hours as such, or even more. Not dealing with the construction, but not dealing with the working of such laser system, because we simply have a lack of time. Applications of helium neon laser include that it's holography in producing 3D images of technology. Also used in scientific and industrial uses, and also other uses as well. Well, we can also have diode lasers, semiconductor lasers, which we have not touched upon before, but they're mainly as such the same kind of lasers where the photon source happens to be a semiconductor. It can actually be intrinsic, or as in a p-type or an n-type semiconductor. P-type could actually be a gallium arsenide system, or and the n-type could actually be a selenium system. As such, moving forward, we can also say that the application lasers include, they've been used in 3D photography, they've used in biomedical sciences, used for welding, used for increasing the speed and efficiency of a computer, used for holography, used to predict earthquakes. It's also been used as surgery tools. It's also been used for communication of TV transmission to objects under the sea, used in fiber optic communication, used in the military like LIDAR, I believe LIDAR, and also used to accelerate some chemical reactions as well. And so thank you for listening on me, especially for this video. It's been a lot of fun. Talking about the general concepts of lasers itself is a very vast topic, so I've just really compressed into cut bits and pieces of the most important points which I think I should convey through this video. So once again, thank you for watching the video, and hope it's been a very knowledgeable experience. Hope to meet you guys again. Thank you for watching one more time, and peace.